Today we will talk about overvoltage cutoff device. In Charvy Electronics, we have two types of overvoltage cutoff devices. One is with 10 amp relay and another one with 30 amp relay. OVCD stands for overvoltage cutoff device. An overvoltage cutoff device is a protective device designed to safeguard electronics or electrical equipment from damages caused by excessive voltage levels. The device typically monitors the voltage of the incoming electrical supply and disconnects the load or equipment if the voltage exceeds a predetermined threshold. Let's start with connector details. This is J1 to input AC supply, J2 for digital state reading, and J3 for load or output. And here is the trim pot details. This is R5 to set the high-level cutoff voltage, and this is R12 to set the low-level cutoff voltage. Now have a look at the connection details. Let us have a look at the working of the device. The device is off at 0 voltage, as it is in cutoff state. Now we are trying to increase the low cutoff voltage gradually so that we can see when the device is switching on and the respective upper limit of cutoff voltage. Currently, the device setting for cutoff voltage is 145 volts. So once, if the voltage goes beyond 145 volts, the relay gets on and switches on the device too. When we measure at the voltmeter, we can see that the device turns on when the voltage reaches above the lower cutoff voltage. Similarly, we will measure the upper cutoff voltage as well. We have set the device upper cutoff limit as 248 volts, and we can see the same at the device that it turns off above 248 volts. And respectively, the connected bulb turns on. We can measure the same voltage in voltmeter too. If we increase the input voltage above 248 volts, we can see that the device turns off, and as soon as the input voltage is decreased below 248 volts, device starts working again. So in this way, we can measure the lower cutoff and higher cutoff voltage of the device. As soon as the device input voltage is below the lower cutoff voltage, that is 145 volts, device turns off. Also, when the input voltage goes beyond the upper cutoff voltage, that is 248 volts, device turns off. The device only works within its working input voltage range, that is between 145 volts and 248 volts. Now, we will see how do we set and verify the value for lower cutoff and upper cutoff voltage. We have two trim pots on our board. One is to set lower cutoff and another one is to set upper cutoff voltage. Here we will tune the trim pot that refers to low cutoff voltage. We will set it to 170 volts and check if the device turns on or not when the input voltage reaches above 170 volts. So as we can see, the bulb lights up when the voltage shows 170 volts here. Now we will take one more value for lower cutoff voltage as 130 volts, try to set it as the lower cutoff voltage, and try to trigger the relay to switch on the device at 130 volts. So as we can see, we tune the lower cutoff trim pot to set at 130 volts. Now we will try to vary the voltage at input, and we can see that the device turns on at 130 volts. So the value which we have set for lower cutoff voltage is set and can be verified also. Similarly, we will set and verify the upper cutoff voltage. Currently, the upper cutoff voltage is set as 240 volts. So we can see that the device turns off if the input voltage is increased beyond 240 volts. Now, we will try to set the upper cutoff voltage as 250 volts so that the device keeps working till 250 volts and stops working beyond 250 volts. So the input voltage is 249 volts. But when it increases above 250 volts, the device turns off. This is how the lower cutoff voltage and upper voltage can be set and changed easily using the respective trim pots provided on the board.